Okay, so in the previous lectures, we were doing some questions on limits, and today we will continue the same. And we'll take some questions from which are relevant to JEE examination only. And what I found in my analysis that most of the questions at JEE examination would require you to work according to certain working rules. Okay, so eventually, if you remember the formula and like if you do much amount of practice, you'll be able to get relatively good success in your exam. Okay, so keeping our vision that way, we're going to start with questions. So, okay, so we've already done some. We have already written some formulas relevant to limits, and we've also done a few more things. Okay, so epsilon del approach also I have written, by the way, and one other thing that we've already done was a sandwich theorem. Okay, so what did sandwich theorem say? So I'll write it here. So this was the last thing that we were doing. This is called as sandwich theorem. Okay, or sandwich lemma I might have written there. Okay, so just let me share the screen. So the last thing that we were doing was sandwich theorem, and it says that if f and g have the same limit L, have the same limit L as x approaches a, and if another function, if h is a function such that your hx lies between fx and gx, your hx lies between fx and gx for all x in deleted neighborhood of x equal to a. Why deleted neighborhood? Again, I've told you on the very first day that while we want to evaluate limits, it may be possible that probably function is not defined at x equal to a. So therefore, we talk of something called as deleted neighborhood. So I'm rewriting this thing that we were doing in the last lecture. That was called as the sandwich theorem. If fx and gx have the same limit L as x approaches a, and h is a function such that hx lies between fx and gx for all x in the deleted neighborhood of x equal to a, means probably it may be possible that at x equal to a your function is not defined. Let's say the first thing that we did was x square minus 4 upon x minus 2, and we were interested in finding the value at x equal to 2. So probably we know that in the limit we can only take a limit. We cannot exactly define my function at x equal to 2. So we are in the deleted neighborhood of x equal to 2. This is how we write things. Is that clear? So we remain in the neighborhood of 2, but we delete 2 because exactly 2 your function is not defined. So therefore I have written for all x in the deleted neighborhood of x equal to a, then limit x tends to a, h of x will also be equal to what? L. Is that clear? So this is what is the sandwich theorem. Harshit, is that clear?
Yes.
Okay. So let us do one question that we like. I think if I correctly remember, I just gave you the last question that I gave you was this. Okay. So let us understand this concept with this example. So the question that I gave you was limit n tends to infinity a ki power n divided by n factorial, where a belongs to positive real numbers. Is that clear? This is what the question was we wanted to discuss in last class. We ended the last class in. So see here the limit is n tends to infinity, so n can grow as large as possible. So n can grow as large as possible, and a is any positive real number. So let us think that your a must be between some integers. It can be between two consecutive integers, isn't it? where lambda belongs to natural number, because a is some positive real number. So let us think that, let's say, if a is 4.5, then it would be between some natural numbers only, isn't it? Yes or no? This is something that can be assumed.
Yes, sir.
So what I'll do, I'll write a ki power n upon n factorial as simply a into a dash dash dash, and this particular thing I will write lambda times. So this particular thing I'm writing lambda times. And then again a into a dash dash dash, all these things I will write it for n minus l lambda times. Is that clear? And this whole divided by what is n factorial? N factorial is 1 into 2 into 3 dash 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 till lambda, and then lambda plus 1 into lambda plus 2 dash dash n. Is that clear?
Yes, sir.
So this entire thing can be written as a ki power lambda upon lambda factorial. And then what can be done is the remaining terms I'm just going to illustrate like in this fashion. So at times, exam में क्या करना होता है? At times, even if you do not have inequality, you can generate inequality. Okay? Even if you don't have inequality, you can generate inequality. कैसे? Let me show you. So you see that lambda plus 1, lambda plus 2, lambda plus 3, and all these things are here. So what one can do is, I know that if I am dividing by lambda plus 2, so lambda is positive, plus 2 is positive. So if I compare lambda plus 1 and lambda plus 2, will this not be an inequality? Because you see, if you divide with a higher number, like if the denominator contains the bigger one, so obviously this would be inequality. This inequality can be understood. Is that clear?
Yes, sir.
A की जगह तो A है, and the denominator you are dividing the greater quantity. Lambda plus 2 obviously greater than lambda plus 1. So if you divide with a greater quantity, this will be small, isn't it? And so on and so forth. This is how I can do, right? Isn't it? Is that clear to you? So
Yes, sir.
okay. So what trick I will play? One thing is very much clear that your this particular thing would be greater than 0, because your a is greater than 0, lambda obviously factorial is obviously greater than 0, and because a is greater than 0, power lambda would be greater than 0, and it would be less than if you just write sorry, lambda ki power n upon sorry. So I know that my a is positive, n is positive, and n factorial is positive. So obviously, in any case, this would be greater than 0. So I have written this greater than 0. Is that clear? And what I'll do, I'll write.
Yes, sir.
Just pay attention to this. The a ki power n upon n factorial is equivalent to a ki power lambda upon lambda factorial. And if I want to bring inequality, what I'll do, just look at this. So this is a upon lambda plus 1, fine. But now a upon lambda plus 2 would be greater, or a upon lambda plus 1 would be greater? Clearly, a upon lambda plus 1 would be greater as compared to a upon lambda plus 2. So instead of a lambda plus 2, I'm now writing a upon lambda plus 1. So initially, a ki power n upon n factorial was equal to a ki power lambda upon lambda factorial in all these terms. Now, since I am replacing a upon lambda plus 2 by a upon lambda plus 1, so you can clearly see that this part would be greater than. So this part would start becoming greater. Should I repeat it?
No, sir, I got it.
You got my point now? So basically,
Yes, sir.
instead of all these things, now I'm replacing all these terms by a upon lambda plus 1. You can clearly see that this side would be greater than a ki power n upon n factorial, because a ki power n upon n factorial eventually is this. And all
Yes.
these terms, like all these terms, you can see a upon lambda plus 2 would obviously be less than a upon lambda plus 1. A upon lambda plus 3 would obviously be less than a upon lambda plus 1. And a upon n would obviously be less than a upon lambda plus 1, because lambda plus 1 is less than n. So anything being divided by a lesser amount would obviously amount to this inequality, isn't it?
Yes.
And you would be thinking why I'm doing this. Let's say, just give me a minute. So this will resolve your doubt. So this will be less than a ki power lambda divided by lambda factorial. And why tactically I chose this? Because see, a, I hope I was writing between lambda and lambda plus, isn't it? So from this I can clearly say that a upon lambda plus 1 would be less than 1. So this bracket,
Yes,
if you
sir.
see, this bracket, it would be a upon lambda plus 1 raised to power n minus. Is that clear? This bracket, I mean, these terms are how many number of terms are here? So these are, I think, n minus lambda terms, is it?
Yes,
So
sir.
n minus lambda terms here. So if there are n minus lambda terms here, so this a upon lambda plus 1 raised to power n minus lambda. So if you see on this side, on the right hand side, if you see, and if I take the limit on both of the n's, so this is 0. So I'll write limit n tends to infinity, a ki power n upon n factorial. This would be less than writing limit n tends to infinity, and this is a ki power lambda upon lambda factorial. And see, a upon lambda plus 1, and there would be another number, let's say a upon lambda plus 1 raised to power minus lambda. I'm not bothered about it because after all these terms, on all these terms, there is no limit. So lambda would be some finite number, but there is an infinite limit here, a limit here, which tends to infinity. And understand that a upon lambda, a divided by lambda plus 1 is less than 1. And on the very first day, I taught you this, that if I want to find limit n tends to infinity, a ki power n, it would be 0, provided a lies between 0 and 1. So one can clearly see that a upon lambda plus 1, this particular term would obviously lie between 0 and 1, because this is positive, but it would be less than 1. Because I've written that my a is any positive real number, so obviously it would be it can be written in between two consecutive integers. Is that clear? So overall, in this limit, n tends to infinity would go to 0. See, a upon lambda plus 1, this particular term is less than 1 and raised to power n. And if I'm telling n tends to infinity, where it will go? It will go to 0, isn't it?
Yes, sir.
Is that clear? Pakka,
Yes, sir.
so from here also it is 0, from here also it's 0. So this kind of function, I mean, this function limit n tends to infinity a ki power n upon n factorial happens to be sandwiched between the two limits, and both of these limits are tending to 0. So I come to a conclusion that limit n tends to infinity a ki power n upon n factorial is 0. I hope it is clear.
Yes, sir.
So this is why this sandwich theorem is quite important as far as your JEE part is concerned. Okay. So okay. So we've done
Yes, sir.
quite amount of questions. कुछ questions हमने कर लिए थे, कुछ questions हमें करने बाकी. So today also I'll focus more on your limits part, and then we'll come up to we'll come to your continuity. Okay. So try to do this question, which I'm giving it to you. I think. Okay. Try to do this question. So let's say if I give you this question, I think we've done this question, but if you want to do it again, so this is r equal to 0 to n, and you have r x greatest integer divided by n square, and I'm summing it up, okay, and I'm putting a limit. Okay. So what would be an answer to this? What would be an answer to this? One can clearly see that your greatest integer x always lies between, is always less than equal to x, and it is always greater than x minus. Is that clear?
Yes.
Since this is the case, one can clearly assert that your rx, the greatest integer, can be written as less than equal to rx, and then you can write rx minus. Okay. And if I sum on both of the sides, if I sum n equal to 0 to infinity, and here if I write rx greatest integer, this would be equivalent to writing r n equal to, where is this n? Sorry, this is r, sorry. R equal to 0 to n, sorry, this is n, and then this is r, and this is x, and this is equivalent to writing sums r equal to 0 to n, and you have this rx minus. Is that clear? And then you can divide all sides by, I think I can divide it by n square. And then this is sums r equal to 0 to n. You have rx divided by n square. And then you have this summation r equal to 0 to n. You have rx minus 1 divided by n square. And so you know that if you know that summation r equal to 0 to n, this r is equivalent to writing n into n plus 1 divided by 2. If you remember, this is sum of n natural numbers. Sorry, there is a
Yes.
0 also. And so 0 will not contribute in general, because you see, if 0 is there, what is the difference it's going to make? It's not going to make much difference. So it is going to be n into n plus 1 by 2. So in any case, this is n into n plus 1 by 2. And there would be an n square, and there is x minus this 1 upon n square, because there is a sum over 1. So if a 1 is summed n times, so it will give you n only. So this will be n upon n square here, and this is the sort limit we want to find. So I'll take limit n tends to infinity on both of the sides. So this will give you the sums are equal to 0 to n, and this is greatest integer rx divided by n square, and then this limit n tends to infinity, and then you have this sums are equal to 0 to n, and then you have, again, I mean, I should not write sums now. I'll write n into n plus 1 by 2, and then I have n square, and then I have x. Is that clear?
Yes.
Okay, good enough. So overall, from here, it's quite evident that if you take n square common out, overall this will become x by 2. From here, limit is x by 2. From here also, limit is x by 2 only. That is from right hand also, this is x by 2. And on left hand also, it is x by 2. So I come to a conclusion by sandwich theorem. By sandwich theorem, I would write that that the limit n tends to infinity, summation r equal to 0 to n, greatest integer rx divided by n square would be equivalent to writing x by 2. Is that clear?
Yes.
Okay, good. So I hope this sandwich theorem now you can do questions when it comes to sandwich theorem. Isn't it? Okay.
Yes.
Okay. So let us do a few more questions. And then we'll see. So just a question. It's not actually based on sandwich theorem, but just to check that if I'll do it. I mean, anyway, I'll do it. But just one of the concept I want to reiterate today also. Always remember that limit n tends to infinity, a ki power n is equals to 0 if a lies between 0 and 1, and it is equal to infinity if a is greater than. Okay. This is very important. This is very important because this is quite understandable. See, because if you're taking it very large numbers on the previous lecture also, I explained it using an example by taking a is equal to 1 by 2. Okay, so if you remember that example, you must admit that this indeed be the case. Okay, and here I want to evaluate. Like, let's say this is the question, and I want to evaluate n tends to infinity, and let's say this is the question: 1 ki power 1 upon sine square x plus 2 raised to power 1 upon sine square x plus 3 raised to power 1 upon sine square x plus dash 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 n raised to power 1 upon sine square x, and this whole raised to power sine square x. Okay, so how to think in such situations? I mean, how to think in such situations? So see, the limit is going on n tends to infinity. It's not going on x. So don't like jump to conclusion, because at times there is a problem, because हम कभी-कभी क्या करते हैं, question ही ढंग से नहीं पढ़ते. So understand that this limit is going all over n. It's not going over x. Okay. So what I would do is let us first think about what. And another thing that I would recommend you or anybody who's preparing for competition, whatever meaningful you can write in a question, write that down. At least कुछ तो life easy हो जाएगी ना. So for all x belongs to R, you would admit that your sin x mod is always less than equal to 1. And indeed, I can write that my sin square x would always be less than 1 and obviously greater than 0. And 1 upon sin square x would always be greater than equal to 1. So in any case, for all x belongs to R, this power 1 upon sin square x will always be greater than 1. Is that clear?
Yes, sir.
So एक काम करते हैं. Let us I'll write, let us write this 1 upon sine square x as t. Okay, so at least things would become easy for us. Okay, let us write this t, and obviously from inequality that I had developed just now, my t would be greater than equal to. So if I use that up, so now I'll write limit n tends to infinity. This is simply writing 1 upon 1 plus t, 2 की power t, 3 की power t, dash dash dash, n की power t, and then there would be raised to power. I think I should write 1 over t. Okay.
Yes.
What do you think can be done? What do you think can be done? Whenever you have n tends to infinity, what is one thing that you do? You actually take this common out. Like you take the largest term common, isn't it?
Yes.
This is what you do. So you just take n की power t common out. So if I take n की power t common out, okay, if I take n की power t, there's a mistake, there's a mistake in the question. It was, sorry, it was x tends to 0. Okay, chalo, if you take n tends to infinity, if you take n common out, in any case, this will give you n की power t raised to power 1 upon t, and then this will be 1 upon n raised to power t, and this will be 2 upon n raised to power t dash 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 1 upon 1 raised to power t, isn't it?
Yes.
Whole raised to power t. So overall, this particular limit would go to infinity, isn't it? Because this n की power t, this t would get cancelled, and this n remains. Okay.
Yes.
Is that clear? So I think I made a mistake.
Yes.
So I'll redefine the question. So let me redefine the question. Okay, let us redefine this question. Let us, so this question, if it is asked, then answer would be infinity. Let us write limit x tends to 0. And I think this should be the question then. I thought there is a certain mistake in the book. I think this should be the question. Now do this question. Okay. This is raised to power sine square. Okay. Now, if this is the question, how would you do the question? So, chalo, kuch to naya hoga isme. I think this should be the question. I think there's a certain, I think, but otherwise, agar book mein ye question hai, then answer would be n. Okay, in any case. Okay, but agar ye question aa gaya, to kya kare? Now, what would you do? Again, the same steps would be there. Sine square x in any case would be less than equal to 1 and greater than equal to 0. So 1 upon sine square x in any case would be greater than equal to 1, less than infinity. That is very much clear. Okay. So in any case, this particular term, if I write t as 1 upon sine square x, then obviously my t would be greater than equal to 1. So all these three things one needs to remember. Okay. Now, if I write limit, let us say limit, what is there? X tends to 0. And this is equivalent to writing 1 की power t, 2 की power t, 3 की power t, dash dash dash, n की power t, and this whole raised to power 1 over t. Okay. And if I take this n common out, what will I get? I'll get 1 upon n. Okay, 1 upon n. तो बातें देखते हैं. So n बाहर आ जाएगा and there will be 1 upon n की power t. अच्छा, x tends to 0 है. So if x tends to 0, where will 1 upon sine square x go? 1 upon sine square x would go to infinity, isn't it?
Yes, sir.
Yeah, and 1 upon sine square x t. So instead of writing limit x tends to t, should I not write limit t tends to infinity? Because see, now my limits are not on x now because I have changed the variable, right? So if I've changed the variable, if I've taken t is equal to 1 upon sine square x, so let us put the limit on t instead of putting limit on x. So this would be 2 upon n raised to power t, and this will be 3 upon n raised to power t, and this would be dash 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 n upon n raised to power t and whole raised to power 1 t. Is that clear?
Yes.
And now it's quite clear that t tends to infinity, 1 upon n would be less than 1, 2 upon n would be less than 1, 3 upon n would be less than 1. In fact, n minus 1 upon n would also be less than 1, barring this. This would be equal to 1. So all these terms would be less than 1 and 10. This limit is tending to infinity. So overall, one can write that these limits would go to 0. Isn't it? Only one
Right.
surviving limit would be this, and this limit would come out as 1 because 1 raised to power anything, be it infinite also, this will give you 1. Okay.
Yes, sir.
Otherwise, also, if you see this t would get cancelled, so overall this is 1 by 1. So answer would be equal to what? N. Is that clear? Not clear?
Yes, sir.
Okay, good. Now, just give me a minute. I'm just giving you a question. You try to do this question, and I'll give you around 1 minute to solve this. If you can think of this question, then it is good. If you cannot think, then it's fine. I'll do it for you. Just find me this limit. Limit x tends to 1 secant inverse of 1 minus x. 2 minus x divided by x squared. Just take a minute or so and try to solve this.
Yes, sir.
Okay. So what do you think an answer would be?
Sir, is the answer 0?
Let me see. So, whenever I told you on the very first day, whenever you have these kind of things, so, at least first start doing some left hand and right hand limits. Let us take left hand limit. So what would be left hand limit? Limit h tends to 0. It will be equivalent to writing secant inverse 2 minus 1 minus h divided by 1 minus h the whole square, isn't it? And it will give you
Yes, sir.
around secant inverse 1 plus h, and h tends to 0, and this would be 1 minus h the whole square. And secant inverse 0 is what? It is equal to 1. Secant inverse 1 is equal to what? 0.
0. Yes, sir.
Left hand limit will get 0. There is no doubt regarding
Yes, sir.
it. But once you're finding right hand limit, now there would be a difficulty here. Now if you take limit h tends to 0, and if you want to find secant inverse, and this is 2 minus 1 1 plus of h divided by 1 plus of h whole square. Now there would be a problem because secant inverse, however small, if you want to take towards 1, however small you want to be, however small you take h, in any case your secant inverse, this argument is less than 1, because चाहो कितना भी h tends to 0 ले लो, तो भी you are slightly less than 1. Since you are
Yes, sir.
slightly less than 1, and I have told you that because secant x is always greater than equal to 1, this particular limit will not be defined. And since this particular limit is not defined, so therefore, I told you if the tendency is on one end is not defined and one end it is 0, so I'll write limit does not exist. Is
Yes.
that clear? ये चीज समझ में आई कि नहीं?
हाँ,
ठीक है, तो ये ध्यान रखना जब भी कभी, I mean, I should have given options, but I didn't have option. I just asked you this question. I think similar question I've given to you on the very first day. So always remember this.
Yes, sir.
Okay, always remember this thing. Another thing
Yes,
that
sir.
you should remember is whenever you can, you have this kind of thing. So yet another rule I'll write. I think I should not write it at once. I should give you a few more questions before doing it. So just do one more question. This question is limit x tends to 0, fractional part. This is fractional part. Remember, this is fractional part. Sin x upon x. How would you do this question? Okay, so whenever you have this fractional part of x, if you remember what is fractional part of x, fractional part of x can be defined as x minus greatest integer of x. Is that clear?
Yes, sir.
Okay, so fractional part of x is equivalent to writing x
Sir,
minus.
is the answer 1?
Answer is 1. Good. So let me write it as x tends to 0, and this is sin x divided by x minus greatest integer of sin x by x. And on the very first day, I told you that in principle, always remember that sin x is always less than x. ठीक है, ठीक है, ये मैं मान लेता हूँ तुम्हारी बात कि tends to 0 केस में they will be almost equal. Tends to 0 case में they will always be equal, but always this would be the case that sin x would always be less than x. ठीक है, example से ले लो.
Yes, sir.
Let's say example ले लिया pi by 6. What do you think pi by 6 should be? So even if you approximate your pi to be 3.14 or something divided by 6, it should be around 0.5 plus something. Is that clear? 0.5
Yes,
plus something.
Yes.
However small, but it would be 0.5 plus something. And what is sin pi by 6? It is around 1 by 2. It is exactly equal to 1 by 2. So you can see sin
Yes.
pi by 6 in principle is, you can see from comparison itself, is less than pi by 6. So your sin theta is always less than theta. However, you can see that I told you in the vicinity x tends to 0, they are almost equal. However, you can see here that sin 30 degrees is almost equal to 30 degrees, which is actually pi by 6 when we write in real numbers. So you can see that sin pi by 6 is almost equivalent to half. So it till the range of x, theta equals to 30 degrees also, theta equal to pi by 6 also, almost sin x is almost equal to x. But in any case, if I want to write strictly, I will write that sin x is less than x. Okay, so in any case, sin x by x would be less than 1. And if it is less than 1, then the greatest integer sin x by x in the limiting case would be equal to what? 0. Okay, since this is 0, so forget about this. This answer would be 1. Is that clear?
Yes.
Now let me give you a slightly tricky question. And this is really tricky. Let us see if you can do it. And now I'm doing two limits. Limit m tends to infinity, and then I'm writing limit n tends to infinity. There are two limits now. And I'll write 1 plus cos ki power 2m, and then I'm giving n factorial, and then I'm giving you pi x. Don't worry about it. I'll solve it for you. Just remember the concept. Actually, all these questions we do in slightly higher classes, but somehow, I mean, JEE has raised its
So is
level.
this fractional part?
No, it's not just fractional part. It's just it. It's just it. It's not even fractional part. It's just a bracket. Okay.
Okay.
Okay. So I'll solve it for you. Don't worry. So just, I mean, you just visualize this question. You just think about it. कि इसका क्या हो सकता है, and I'll let you. So what I'll do with this question is, I'll take two cases. Okay. So let us first understand what I can conclude from this question. So one of the things that you can conclude as a standard 11 child, that cos theta ka mod is always less than equal to 1 mod for all theta belongs to R. Okay, for all theta belongs to R, cos theta ka mod is always less than equal to, isn't it? So
Yes.
इतना भी कंफ्यूज कर दे तुम्हें, मतलब कुछ भी लिख दे अंदर, you should remember that your cos your n factorial pi x, चाहो तो इसको तुम लिख लो कोई वैल्यू, लेट्स से p लिख लिया, it will always be less than, मतलब mod भी ले लो जिससे कि लाइफ इजी हो जाए, this mod will always be less than, isn't it? मतलब cos में कुछ भी लिखा है अंदर, x रियल को बिलोंग करेगा, pi है और n factorial, ओवरऑल कुछ भी हो अंदर, I can write that this modulus, which let's say it is equal to p, it will always be less than, isn't it?
Yes.
So if I take this, I'm doing it for you, like तुमको easy रखने के लिए मैं ऐसा कर रहा हूँ. Let us say, is it not effectively writing? Is it not effectively writing limit m tends to infinity, and this entire thing I have like whatsoever be the case, like even as large as you may take this n, overall this particular term would be less than 1. So it is equivalent to writing 1 plus p ki power 2m, isn't it? It is equivalent to finding this limit. Here p is
Yes.
this cos n factorial pi x, where n tends to. Okay, so मैं तुम्हें सिर्फ एक हल्का सा आइडिया दे रहा हूँ कि ऐसा सोचो. Is that clear?
Yes.
अब थोड़ा सोचते हैं कि अगर ये p की वैल्यू, if this value of p is equal to 1, है ना, दो पॉसिबिलिटी, लेस देन इक्वल टू 1 ना, cos n factorial pi x would be less than equal to 1, मानते हो?
Yes, sir.
है ना, अगर ये इक्वल टू 1 हो जाए तब आंसर क्या हो जाएगा? 2.
Yes, sir.
और अगर ये लेस देन 1 होगी तो आंसर क्या जाएगा? 1.
1.
बिकॉज p की पावर 2m, मतलब समझ पा रहे हो ना कि अगर
हाँ,
m tends to infinity, if I want to evaluate, then p की पावर 2m, it will be equal to 0 if p is less than 1, मानते हो?
Yes, sir.
Okay, so this is one thing that you should think of. Okay, now what I want to convey is, चलो तो अब ये तुम्हारा थॉट पैटर्न होना चाहिए सोचने का. अब ये सोचो कि n factorial any case would be some like this kind of expansion, n minus 1, n minus 2, n minus 3, और मतलब समझ पा रहे हो, like इस तरीके से कुछ चलेगा 3 to 1. Okay, now I'll take two cases here. If x is some rational number, x is some rational number, a rational number can be expressed in the form p by q, मानते हो?
Yes, sir.
And remember this n is tending to infinity. So n is tending to infinity, मतलब समझ पा रहे हो? This n factorial expansion will contain all sort of integers, all sort of natural numbers, isn't it?
Yes, sir.
As large as possible. In any case, if x belongs to some q, what I can say that there would be some q in between. मेरी बात समझने की कोशिश करो. Let's say if x is a rational number, और ऐसा समझो, देखो ऐसा मत समझो, तो ऐसा समझो. Let's say if n factorial pi x is some k pi, ऐसा कुछ लिखिए. अगर ये k pi के बराबर होगा तो this pi would get cancel, x would be equals to what? K upon n factorial, मानते हो?
Yes, sir.
और k क्या इंटीजर है, है ना, समझ लो।
हाँ सर।
सोचो ना, अगर ऐसा कुछ हो जाए, मैंने बताया ना कि अगर ये 1 हो जाए तो ओवरऑल लिमिट क्या हो जाएगी, 2 नहीं हो जाएगी। सो इफ x इज सम k अपॉन n फैक्टोरियल का मतलब क्या है, इफ इट बिलोंग्स टू सम रैशनल नंबर, या फिर ऐसा समझो इफ आई टेक सम p by q। अब ये p by q का मतलब क्या है, कुछ तो ये फाइनाइट नंबर्स होंगे p अपॉन q, या n क्या है, इट इज infinitely large, so it will contain all possible natural numbers. Like in this expansion you will find all sort of possible natural numbers, isn't it? So your n factorial
Yes.
p upon q in the limit n tends to infinity will be an integer, and in fact a positive integer.
Yes.
Are you getting my point?
Yes. sir.
देखो मैं कह रहा हूँ, लेट्स से दिस p अपॉन q, और अगर तुम्हें बिल्कुल इसको और जनरलाइज रखना है, इट विल बी सम इंटीजर, अगर नेगेटिव पॉजिटिव दोनों लेने तो खुद सोचो, n फैक्टोरियल के अंदर ऑल पॉसिबल नेचुरल नंबर्स आ जाएंगे। अगर तुम n को लार्ज से लार्ज ले रहे हो तो n इंटू n माइनस वन, n माइनस टू, n माइनस थ्री, तो ये कुछ ना कुछ p बाई q में, ये जो q है नीचे वाला, ये भी तो कुछ ना कुछ टर्म बना ही लेगा। लेट्स से
हाँ हाँ
तुम्हारा
सर।
ये p अपॉन q है, मान लेते 22/7, तो क्या 7 यहाँ पे नहीं आ जाएगा?
हाँ सर।
लेट्स से ये है 383 डिवाइडेड बाय 212, तो क्या 212 बीच में कहीं नहीं दिख जाएगा तुमको? आर यू गेटिंग माय पॉइंट?
हाँ सर।
Because
Yes.
this n is tending to infinity, so it will contain all sort of this expansion will contain all sort of natural numbers. So n factorial p by q in the limit n tends to infinity will belong to ultimately an integer, isn't it? So if x belongs to q, n factorial pi x would be equivalent to some k pi, isn't it? Because n factorial into x, so n factorial into x is some integer, mante ho?
Yes. sir.
And this will be equal to k pi, and where k belongs to integer, isn't it? Now,
हाँ
what
सर।
is cos k pi? You know that cos k pi is minus 1 की power k. And what would be cos to m k pi? It will be equals to simply 1. So this limit would then be equals to 1. So I'll repeat it because the time is less. So I'll give you another link and join that link. Okay.
Yes sir.
Okay.